Hello everyone. Today we are going to explore something fascinating. The Collatz Conjecture many generalizations. The Collatz Conjecture is famous for being one of the simplest unsolved problems in mathematics. But what if we change the rule slightly? What if instead of 3n+1 we try 3n+5, 3n+7, and so on? By studying these generalizations, we can gain a deeper understanding of the original problem, and maybe even find clues that could lead to improve. Let's do investigate it. The original conjecture, we have the called 3n+1 problem. Start with any positive integer, and if n is even, then the result is n over 2. If n is odd, then result is 3n+1. Does this conjecture every sequence lead to 1 or not? Why generalize? Understand the structure of the problem. Find patterns that may lead to a proof. Discover new family of similar problems. Reveal hidden symmetries. The first generalization is 3n+b family. In this family, the rule if n is even, then result is n over 2. If it's odd, then 3n+b is a result. B is odd, the GCD of b and 6 must be 1. Here we have some examples for different group of this family. 3n+1, 3n+5, 3n+7, and 3n+11. The sequence is 7, 22, 11, 34, and 17, and so on. The 3n+1 converge to 1. 3n+, fine, although the sequence example has been generated here and converge to 5. 3n+7 converge to 7, but it has a cycle. And 3n+11 also generated the sequence like this, and it converges to 1. Different value of b create different cycle and behavior. Some converge to b itself, and some converge to 1. The second generalization is 3n+3 to the k family. If n is even, then the result is n over 2. And if n is odd, then the result is 3n+3 to the k, for k greater than or equals to 1. Here also we can see the examples. The family is 3n+3 converge to 3, and it includes cycles. 3n+9, here the sequence example, and converge to 9. And 3n+27, it generates a sequence example, and it's converge to 27 or later cycle. These sequences converge to 3 to the k instead of 1. This shows that the original 3n+1 is just one member of a larger family. Here we are going to compare the convergence behavior. In this graph, we can see the step numbers and the values in a log scale. The different family 3n+1, 3n+5, 3n+7, and 3n+11. We can see that they have different behavior. Some of them converge to 1, some of them converge to some values. Different b value lead to different convergence patterns. Some converge to 1, and some to b, and some into the cycle. Okay. And the second generalization is the ABC family. In the ABC family, for the even case, the result is an over 2. And for odd case, the result is A and plus B over 3. A and B and C are integers. Also, we have some examples for these families. For family 3, 1, 2, the rule is 3n+1 over 2. The behavior is a classic Collatz. And the formula of 3, 1, 4, the rule is 3n+1 over 4. It has also different behavior. And the family 5, 1, 2, the rule is 5n+1 over 2. It grows faster. And the family of 7, 5, 7, 1, 2, the rule is 7, 9 plus 1 over 2. The behavior exclusive growth, it grows exponentially. The value of A determines the growth rates. If A equals to 1, give contraction. And if A equals to 3, give the classic case. For A larger than 3, gives divergence. So the different value of A and B creates the different behavior for the Collatz generalization. Also here we can see in this graph, we can see the growth phase. We can see that the different pattern for the pattern 3, 1, 2, 5, 1, 2, 7, 1, 2, and 1, 1, 2. The 1, 1, 2 and 3, 1, 2, they have the linear behavior. But for the case of 7, 1, 2 and 5, 1, 2, they grow very fast. Larger A value cause faster growth and eventual divergence. A equals to 1 give rapid convergence. This is the traditional Collatz. And final one, the fourth generalization is the Hydra map. The Hydra map extends scholastic global field and periodic numbers. The periodic numbers completely is different from the normal number that we use in the daily life. The key features work in algebra number fields, use periodic analysis, label universal pattern, connect to a modular form. Why it matters, this generalization suggests that Collatz is a part of a larger mathematical structure that may be understood using advanced number theory. Already in this table, we have some statistical comparison of the families, the convergences of different families. The family of 3n+1, the classic one, the convergences is 100%. Also, this result is for n less than 100, not for all integer numbers. So for 3n+1, the convergence is 100%. The maximum steps for 3n+1 is 118. The pattern converges to 1. 3n+5, also for n less than 100, the convergence is 100%. The maximum steps is 15. And also it converges to 5. 3n+7 convergence is 100. The maximum steps is 10 and converges to 7 and also it has cycle. 3n+11 convergence rate is 100%. Maximum steps is 20 and also it converges to 1. 5n+1, the convergence rate is 50%. Because it is diverse, so we couldn't define the maximum steps it often diverges. 7n+1 convergence rate is 10%, although the maximum is not available and almost always diverge. So for this family, we have different behaviors. The T inside the coefficient A is n plus B is the most important factor. A equals to 1, always converge. A is equal to 3 is critical case. For A larger than 3 usually diverges. Also, we have comparison or visual comparison of sequences. For classic Collatz 3n+1 converges to 1. Here is the sequences that generated with starting with 7. After this sequence, it reached 1. And for 3n+5 enter the 8th cycle. We can see here the bold number, the entering cycle. And for 3n+1 also it enters 3 cycle. The 3 cycle is 14, 7, and 28. And for 3n+11 it converges to 1. It converges to 1. And 5n+1 it diverges. Here we can see that it grows and diverges. The summary of the presentation is comparing Collatz and its generalization. The key findings are 3n+1 is just one member of the larger family. 3n+b different b gives different convergence. 3n+3 to the k converges to the 3k instead of 1. And the family of A, B, C, A is equal to 3 is the critical case. And the last family is Hydra map, connected to Atlas number theory, the p-adic numbers used in the Hydra map. Why this matter? Understand generalization help understand the original labels, structure, and pattern may lead to new proof strategies. And show the leastness of the problem. Only the 3n+1 or the traditional Collatz is one member of the this family of Collatz series. The Collatz Conjecture is part of vast mathematical landscape. Also here, there are some challenge. Maybe you try this. Find the convergence behavior of 3n+. Compare 3n+1 and 3n+5 for number 1 to 50 or more. Can you find a family that always converges to 1? What happens when A is negative? In next video, we talk about the negative case. Although you can write a program to test different ABC families. Look for pattern in convergence. Visualize the difference. Maybe we can get some fractal behavior of these patterns. If you can share your findings. Thanks for watching. See you in next video.